Welcome back. In this lecture, I'm going to have you do a drill, and this is a little bit more extensive, and I expect it'll take a little bit more time, so make sure you carve out maybe a half hour or so, because there's a couple of moving parts. You'll see when it's done, it's relatively straightforward, but there's a couple of moving parts, and I want to make sure you have time to do it. Okay, I'm going to, as promised, ask you to write a crowd class. So the first thing you should do is get the eye and the face class into your notebook and make sure that you can run them and everything works. Your crowd class, like the eye and like the face class, should have three functions: a constructor, a lookat, and a draw function. The constructor should take as input a number n and create a list, that word is very important, of n faces. So first of all, when I say n faces, I mean that you should be calling the constructor to the face class, which, by the way, we'll call the constructor to the eye class, but you really don't care about it at that point. And you should build n of those and shove them into a list. And you're going to see in a little bit why I want them into a list. The lookat function should have each of the faces look to a random location. So when I call lookat, it will no longer take an lx, ly parameter. It will take each of the faces that you put into your constructor, and it will have them look at some random direction. So pick a random direction between 0 and 360, or a random point, I don't care how you do it, and have the face look in that direction. And then the draw function should draw all of the faces on your canvas. Now, a couple of things that are important here. This lookat function should not be messing with the data associated with the face. You, of course, should be calling the faces lookat function, which itself will call the eyes lookat function. And same thing with the draw. You should not be in the business of drawing faces, that is, drawing the circle and the nose and the mouth. You should only be in the business of calling the faces draw function, which does all of the hard work for you. So in some ways, you want to be as lazy as possible in this class and use all of the member functions that have been defined for you in the eye and the face class. Now, I don't care how big you make it and how many faces, but if you want to follow my lead on this, my canvas was 800 by 800. I made them a little bit bigger so I can draw more faces. I was testing it with 25 faces. And by the way, it's okay if the faces overlap. I don't care. And each face was of size 100. And that'll get you a reasonably dense, and you'll be able to see what's going on. And you'll be able to see when it's rendered, the face should be looking in all different possible directions. Okay, take a little time to do that, and when we get back, I'm going to show you my solution. Let me show you my solution to the crowd class. So first things first, I'm going to import some libraries. I'm going to need the uniform function from the random library, because I'm going to pick random locations for the eye to look. I'm going to bring in the eye class as is from before. I'm going to bring in the face class as is before. And here is my crowd class and a little driver. So first, let me just show you the output. Yours should look something like this. You can see a bunch of faces. They're, of course, on top of each other. That's fine. You can see that they're all looking in different directions. And what you notice here, or you should notice, is this crowd class is awfully simple. I mean, there's not a lot of code here. This is my little driver down here. So I'm going to define a crowd, and I'm going to draw the crowd. And so that's all I had to do for the driver. So let's go ahead and start looking at the three pieces of the crowd class: constructor, lookat, and draw. So the constructor takes as input n. I'm going to go ahead and initialize a variable. I didn't have to do this, but you're going to see in a little bit that it turns out to be a little convenient, but you can just build the list, so it's fine not to do this. I'm going to define the crowd, which is a data associated with the object of type crowd, and I'm going to initialize it to be the empty list. And then for I in range 0 to n, so for n times, I'm going to add a face to that list. So how am I going to do that? I'm going to take the list, the crowd. I'm going to append to it the result of a face. So I'm going to call face with three parameters: a random number for the x location, that's uniform minus 300 to 300. A random location for the y, that's minus 300 to 300, and then the radius, which is 100. By the way, why minus 300 by 300? I define my canvas to be 800 by 800. That means that the canvas runs from minus 400 to 400. Since the radius of my face is 100, this makes sure that when I do draw a face, it won't break off of the canvas. It's no problem. It's not a bug. It's just I wanted to be able to see all the faces in their entirety, even if they were occluded. So uniformly distributed on the canvas. However you chose to pick random numbers for this purpose, I don't care. And notice that that's it. That's the ball game. This list, the crowd, now has in every element of the list, 100 of them or how many I define, a face. And once I have the face object, I can draw the face, I can look at the face, I can have the face look at a point. So now let's look at. As promised, look at takes no input because we're going to tell it to look at a random location. So for I in range 0, and here you can see why I stored this n. I could have just computed the length of the crowd, but as a nicety, I wanted to be able to just tap into that value. So for each element in the list, the crowd, I'm going to call the lookAt function associated with that element of a list, which of course is a face. And I'm going to just pick some random point on the two-dimensional canvas, and I'm going to have the face look at that. Again, how you picked a random number, don't care. If you did it from an orientation and convert it to a number, don't care. And notice here the power of this. There's actually 2 levels of abstraction here. I've got a crowd class. I have a face in there. I'm calling the faces lookAt function. How does that work? Well, it passes the buck down the line. It passes it to the eye class. And the eye class is actually doing the work for the left eye and the right eye. And I have no idea how that's working, and I don't have to. All I have to know is the functionality of the lookAt function of the face, and it takes care of the rest. Now, the draw is going to be exactly the same. I'm going to, no parameters of course, I'm going to iterate over every element of the list. I'm going to tap into the ith element of the crowd, and that again is a face. And all I have to do is call the draw face function associated with that object. Again, don't care about the circle, the nose, the mouth, the arc, the 2 eyes, all abstracted out for me. All I have to know is that there is a draw face function associated with a face object. I've got a face object, so I get to use it. So notice how we built up now 3 classes deep. We built a crowd from a face. A face was built up from the eye, and so on and so forth. And that, in this particular case, you could argue, and it would be a reasonable argument as well, this all seems pretty silly because who else is going to use a face object? And that's absolutely true. But generally speaking, when you build these classes, they have multiple functionalities. And so when you build these general purpose classes that can be used by other classes and other bits of code, you bundle up into one piece, and every functionality, you bundle up functionality to one piece, and then everybody else can use it very, very nicely. All right, I hope you got the drill. If not, please make sure you understand this nested class is a very, very important concept. And when we pick up the next lecture, we're going to be talking a little bit more. We're going to build more and more complex classes. So this is a good time. If you're not getting the core concept of this, make sure you go back and spend some time from the very beginning, because now the classes are going to start to get a little bit more complicated. I'll see you in a little bit.